Welcome to our tutorial on building a blockchain-based auction platform. In this multi-part series, we will take you through each step of the process, from understanding what blockchain is to developing the auction platform using Java and the Ethereum blockchain. Before we dive into coding, let's ensure we understand what blockchain technology is and why it's a great fit for creating an auction platform. Blockchain is a decentralized distribution system that provides transparency, security, and immutability. Each auction can be recorded on the blockchain, ensuring all transactions are secure and traceable, which builds trust among the users. We will specifically be utilizing the Ethereum blockchain for this project. Ethereum allows us to write smart contracts, which are self-executing contracts with the terms of the agreement directly written into the code. To set up our development environment, we'll need a few tools: Java Development Kit, JDK, an integrated development environment, IDE, like IntelliJ IDEA, and the Web3j library for interacting with the Ethereum blockchain. Let's start by installing the JDK if you haven't done it yet. Head to the Oracle website or adopt OpenJDK and follow the installation guides. Once you have the JDK installed, proceed to download IntelliJ IDEA from JetBrains and install it as well. Make sure to configure it to use the JDK we just installed. Next, create a new Java project in IntelliJ IDEA. Name it Blockchain Auction Platform. This will be our main project directory. Now, let's add the Web3j library to our project. Open the build.gradle file and add the following dependencies. After adding the dependencies, make sure to refresh your Gradle project so that IntelliJ pulls in the Web3j libraries. Now that our environment is set up, let's outline the smart contract we will be using for the auction platform. This contract will handle functionality like creating an auction, placing bids, and concluding auctions. Create a new file named auction.sol in a contracts directory. Here is the basic outline of our smart contract. Let's break down this smart contract. We have a struct called bid, which represents an individual bid's details. We also define variables to store the auction owner, highest bid, and highest bidder. In the constructor, we set the auction owner to the person who deployed the contract. The function placeBid allows users to place bids on the auction by sending Ether. Next, let's implement a function to conclude the auction, allowing the owner to withdraw the highest bid. Add the following code to your auction contract. Here, conclude auction allows the owner to transfer the highest bid to themselves, effectively concluding the auction. Ensure you include appropriate visibility modifiers and checks. Now that we have our smart contract ready, we need to compile it. To do this, we can use a tool called Remix, which is an online Solidity IDE. Navigate to remixethereum.org and copy-paste your auction.sol code into it. After you've pasted your code, look for the Solidity compiler icon in the left sidebar, select the version that matches your contract version, and click the Compile button. Once the contract compiles successfully, let's deploy it to a local Ethereum test network using Ganache. Download and install Ganache from truffleframework.com/Ganache. After starting Ganache, it will give you an interface with accounts and their addresses. You will see some test Ether in these accounts, which we can use for deploying contracts. Now back in Remix, switch to the Deploy and Run Transactions tab. Make sure to select Injected Web3 environment so Ganache can provide a local Ethereum network. Then connect to your Ganache network. Select our compiled auction contract from the drop-down and hit Deploy. After deployment, you will receive the contract address which you need to keep for later use. Now let's begin interacting with our smart contract programmatically through Java. Create a new Java class called auctionplatform.java in your main project directory. First, we need to set up the Web3j service to connect to Ganache. Here's the code to get you started with Web3j. In the constructor of Auction Platform, we initialize Web3j by connecting to Ganache's default RPC endpoint. Make sure Ganache is running when you try to connect. Next, let's add methods to our Auction Platform class that will allow us to create an auction instance and place a bid. Begin by adding a method to deploy the auction contract. This method deploys the auction contract and returns the contract address. The constructor takes the Web3j instance, the owner's address, and the gas provider. Next, let's implement the placeBid method, which will allow users to place bids. In this method, We load the auction contract using its address and invoke PlaceBid. Users will need to authorize the transaction. Make sure to handle exceptions properly in a real application. Once we have our deploy and bidding methods, we should also implement a method to conclude the auction. This will let the owner of the auction retrieve the funds. Here, we follow the same loading pattern for the contract and call the conclude auction method. With the core functionality in place, let's test our auction platform. Create a main method and include code to deploy an auction, make bids, and finally conclude the auction. Ensure you replace your owner address, bidder address, and second bidder address with the appropriate Ethereum addresses from Ganache. When you run your program, it will deploy your auction contract, simulate 2 bids, and allow the owner to conclude the auction appropriately. Congratulations! You've just built a basic blockchain-based auction platform using Ethereum and Java. Remember, this is a fundamental project. From here, you can enhance features such as a bidding history, timestamps for auctions, or even a front-end interface. Before we wrap up, let's summarize what we've learned. We discussed blockchain fundamentals, built a smart contract for auctions, and created a Java application that interacts with this contract. In future tutorials, we'll expand on this project by adding additional features such as user accounts, a front-end web application using React, and integrating IPFS for decentralizing the auction assets. Finally, if you enjoyed this tutorial or have any questions, please let us know in the comments below. Don't forget to like and subscribe for more programming content. See you in the next video.